Worksheets 56 and 58, naming binary compounds with covalent bonds and naming binary compounds with polyatomic ions, and I'll explain polyatomic again when we get to that page. First, on page 56, we're simply going to name the binary compounds. These are covalent bonds. Remember that covalent bonds are between two or more nonmetals, and as you see, carbon and oxygen right there. So all we have to do is write the words. Now remember, with covalent bonds, you want those 6 prefixes. Mono 1, di 2, tri 3, tetra 4, penta 5, and hexa 6. And just remember one simple rule when doing this. We don't put mono on the first element. And that's really the only rule. We'll put all the other ones on the first, and we will use mono and all the other ones on the other ones. All right, now you see number 1 is already done, carbon monoxide. And you see number 5 is already finished, N2. 2 is di, so dinitrogen monoxide. It would be mono-oxide, but we try not to run those couple of vowels together. Okay, so what we're going to do is start here on number 2. So on number 2, we see carbon only once. We don't put mono, we just say carbon. Now, oxygen has a little bitty 2, and that is Di, and just like with the ionic bonds, the last letter becomes IDE, so the end of it becomes that. So number 2, carbon dioxide. All right, go on to number 3. If I can get it on there to number 3. We have sulfur. Lost my keyboard, so sulfur. The 2 means di, so Di oxide. All right. Number 4, slightly different. No problem. Nitrogen, we don't put mono. Now, 3 is tri, so all I have to do is say tri oxide. All right, now I'm going to scroll down to one that has a subscript on both numbers. So number 9, we see N2O5. Well, we had the rule about putting mono, or actually not putting mono on the first element. All the others we do. So number 9 is going to be dinitrogen. And remember 5 is penta, P-E-N-T. Now, thing about here is I'm not going to put pentaoxide. When that happens, we just take off the A and just say pentoxide. So we try not to run pentaoxide or monooxide together. Take off the vowel at the end of the prefix. Okay, number 10. 2 phosphorus, so Di. Phosphorus can be a little tricky to spell if you're not careful. There are actually 2 accepted ways to do it. O-R-U-S or O-R-O-U-S. Since our book doesn't put the second O, I try not to do that. And again, we have P-E-N-T, but take off the A, pentoxide. Okay, don't worry about the red squiggly line. The Microsoft Word's not recognizing that that is a correctly spelled word. And there are only a few on this page, so let's pick one more of these. Number 13. So we'll go here to number 13. Actually, I'm on 14. That's okay. P-H-O-S, P-H-O-R-U-S, phosphorus Tri Chloride. All right, so I'm going to pause here, go on to the other page, let you try the rest of those yourself. So on page 58, we're dealing with polyatomic ions. And remember, a polyatomic ion is, I like to say it as two or more atoms together that pretend to be a single atom. You get a fancier textbook definition, but look here at the NO3. That's nitrogen and 3 atoms of oxygen that when they combine together, since that's on the nonmetal side, they still have room to take more electrons. So they're going to bond with sodium. In fact, the oxidation of NO3, which we call nitrate, is -1 because there's still one more opening on the valence level to take one electron, and sodium will give that away. So just like sodium chloride, sodium nitrate will fit together very, very much the same way. All right, let's pull some more up here. And really, once again, all I have to do is write the names of either the single atom or the polyatomic ion, and that's pretty much all I have to do. So on number 2, I see the element calcium. Oops, my mistake. So number 2, calcium. We'll try to put it there. All right, calcium. And just look at the name of OH. Not worried about the 2 on the outside. That just means there are 2 of these polyatomic ions that we call hydroxide. And now I know it's scrolled down a little bit. That's because the line is a little bit too long. So all I have to do is erase some of that line and it's all caught up. All right, so shorter lines should help eliminate that problem. So again, since it's binary ionic, because those polyatomics actually do make an ionic bond with a metal, we don't really even have to look at the subscripts. All we have to do is get the names. So K is potassium. And just look on your charts. What do we call CO3 in the parentheses? That is called carbonate. So this compound is potassium carbonate. Okay, go on down to number 5. And you'll see Mg, that's a single element. Now the way I wrote these, I put all the polyatomic ions in parentheses. When there's a subscript after it, like number 2 has a 2 on the outside, they have to be in parentheses. If the OH was by itself without the little bitty 2 on the outside, you might not see parentheses. But for what we're doing, we're just learning this, I put every polyatomic ion in parentheses. So look on your chart, what do we call SO4? We call that sulfate. So number 5, oops, misspelled that. Go ahead and correct that. That is magnesium sulfate. All right, number 6. I'm not going to do all of them. I'll do number 6, skip down a little bit, and let you finish this up. All right, number 6, aluminum. And what do we call PO4? Look on your charts. You will see that is called phosphate. Okay, I'm going to scroll down a little bit. And if you look at number 9, you'll see the Roman numeral 2. We talked about that on the previous assignment. The transition metals, many of them have more than one oxidation number, so we have to give it the correct Roman numeral. Well, again, just like we did with single atoms in this situation, we need the oxidation numbers of the second part. So in this case, sulfur, look on your chart, you'll see it's -2 because sulfate will take 2 more electrons. That means copper has to be +2. And that's the reason for the Roman number right there. That +2, I'll make it a little neater for you. That +2 becomes the Roman numeral 2. So this answer is copper 2 sulfate. Might see a couple more of those. Other than that, though, we go to number 10. And Now we have two polyatomic ions. Most of them are going to be the negative and written second, but NH4 is a positive. It has a +1 oxidation, meaning once this combination happens, there's an extra valence electron to give away, just like a sodium atom. Look on your chart, though, you will see this is simply called ammonium. And as we said earlier, OH is called hydroxide. So ammonium hydroxide. Number 11, I won't write it, but you can see lithium. And what do we call SO3? Look on your chart, and you will see that it's called sulfate. So that would be lithium. Or actually, SO3 is called sulfite. So that would be called lithium sulfite. SO4 is sulfate. SO3 is sulfite. Sorry, I didn't name them. I just do them. Okay, I'm going to do two more for you and let you finish this up yourself. Number 18 and number 20. And that's because of something we saw up above a moment ago. Lead has more than one oxidation number. It's a transition metal with multiple oxidation numbers, same as copper. So what we're going to do is we're going to look at the oxidation of the polyatomic ion like we did before. Hydroxide, look, and you'll see it's -1, but it's -1 twice, so that's -2. That means lead has to be +2. That means to answer this, this is now, I'll go ahead and write this one, lead. The oxidation we're using is +2, so that is lead 2 hydroxide. And number 20. And this is the last one on the page that you'll have to do the Roman numeral. All the others, just write the element name and then the polyatomic name. Copper could have more than one possibility. So look at the oxidation of CO3, which is called carbonate. You'll notice that it is -2. That means the copper has to be +2. So this formula is copper +2, so copper 2. And CO3 is called carbonate. All right, so now you know how to write the formulas for a binary compound, even with a polyatomic ion. Go ahead and finish this one up, and we'll catch you next time. Good night.